Hi, this is Mighty CS Man. I have a complete curriculum on teaching Java with the Building Java Programs book, and this is their accompanying website, Practice It. See my week 1 orientation for how to use Practice It. So today we're looking at exercise 5.7. Chapter 5 is about indeterminate loops and also random numbers, and we're doing a little dice game here. So we're going to write this method diceSum that prompts the user for a desired sum. Okay, so that's really one complete operation we need to think about. And then repeatedly rolls 2 6-sided dice until the sum is the desired sum. Okay, that's really a second thing. So I always try to teach my students to really try to plan things out. Don't just start throwing random code at the board. Try to figure out how you're going to do this using some pseudocode. So as I walk through it, identified there are really 2 separate things in here. First, we have to get the desired sum. The second thing is we're going to roll dice until the sum matches. Okay? We always want to look at what we're given and where we need to go, and then what tools we have available to us. So let's take these 2 problems separately. First of all, get the desired sum. So we're supposed to print this out, and then we're supposed to get the integer answer here. So let's think about we're starting from nothing, and what we're trying to do is to get that input. So what are the tools available to us? Well, what should come to your mind immediately is scanner. Okay. So this chapter doesn't do a lot of work with scanners, but I guess because this chapter doesn't do it, we'll go ahead and walk through that. You should know how to do this by now, but we'll go ahead and do that. So we're going to need to use a scanner to get an input. So I'm going to go ahead and declare a scanner, new scanner, okay, and then the parameter here is the system.in. Some of you might think, is it always system.in? The answer is no. You can actually provide a file. We'll be taking care of this or looking into this in another chapter or so. But this is going to get console input, and then we're going to actually have to put a prompt up, right? So system.out.println. Actually, let's not do lin, and we'll instead copy this, and we've got a space, and then we're going to have to get the integer value. So int sum equals sc.nextInt. Okay. And just to briefly remind people, whenever we're dealing with new objects, whether it be random or scanner or any of the things that we're going to be learning about in the future, we always need to use new on that class, okay? And we're going to pass in typically some parameter, okay? And then we're going to assign that like this. I still see some students, even at this point in the class, who are not quite sure what this means. This means that we're declaring a type of scanner. Just like here, this type of int, okay, we're declaring the type of scanner, and then we're just creating it into that variable. All right, so this is going to get our integer. And in fact, let's just quickly do a sanity check. Okay. So what it's going to do, our output is desired sum. Okay, it took the user input, and then we printed it. Now, I've covered this in the past, but I'll cover it once again in this chapter. How is it that this 9 got here? Because we, as the user, didn't type it in, did we? It's because Practice It has its own test harness. When I put system in here, it's actually overriding that and providing a file or a string that it's passing in. So it doesn't have to wait for us to sit around and type an answer. It already knows what the answer is going to be, and it can pipe it in. But anyways, so this code here works. We now have the correct integer sum. So that's half of the problem right there. Second half of the problem, roll dice until sum matches. This is really the focus of this chapter. Indeterminate loops and random numbers. So let's think about where are we coming from? We're coming from this routine here, and this code here, and we've got sum. Okay, that's what we're starting with. So that's important. Where are we going? we want to print out these two different numbers and their sum each time. And these numbers, let's think, where are we coming from? We're coming from nowhere, except that we know that they're six-sided dice, okay? And we want to get two of these six-sided dice rolls, okay? And we know how to generate the sum given those two numbers. So you're going to need some integer variables here for dice 1 and dice 2, okay? You're going to have to figure out how do you generate some value there, dice 2 equals some value there. So if you haven't already seen my self-check 5.5 video, go and take a look at that. That gives an excellent review on how to generate random numbers. You want to generate a random number. Okay, its range is 6 items, but instead of being 0 to 5, you really want it 1 to 6. Okay, so the range is 6 and the offset is 1. Using those two bits of data, you should be able to write the function here in order to generate the random numbers. Okay, so that's how you're going to get this. Okay, you're going to have to do a print, right? And you're going to include dice 1, ... and then dice 2, okay, ... and then you're going to have the dice 1 plus dice 2, okay? You're going to have to print that line. The real trick of this problem is how do you keep on doing it until you get the value of the sum? So I'm really hoping that about now you're thinking, gosh, what have I learned in chapter 5 that can work for this? And you realize this is the infamous Sentinel loop. Okay, this is a really important form for this chapter and for the entire course. Okay, you really need to understand how to identify what a Sentinel loop is and understand how to write it. So how do we identify it's a Sentinel loop? Sentinel loop means that we're doing some process over and over and over again until it matches a Sentinel value. What is the Sentinel value? The Sentinel value we're looking for is sum. I'm going to put that in quotes just because it's the variable sum, okay? Whatever sum is up here, that's the value that we're looking for, okay? And so that's how you identify it's a Sentinel loop. You're looking. So also note that in a lot of cases so far, Sentinel loops have been about user input. So we're asking the user for something over and over and over again. In this case, we're not asking the user. In this case, we're generating random numbers, but that's fine. Okay, Sentinel loops can be computed just as well. So we're going to do it over and over and over again until the value matches sum. Okay. So what is the general form of a Sentinel loop? Now, hopefully by now you've learned that the general form is you're going to have either a do while or a while do, some form of that. Okay, so let's just try the do while loop. I'm going to just leave that blank for the moment. So this here, we're going to have to test the Sentinel value. Okay, as in all cases. Okay, so we're going to test that Sentinel value. We're going to do this loop in here. Let me indent this. Now, a good student will ask, is it always do while? No, it is not. But let's take a look at this particular situation. So again, the two things I'm trying to teach you in this half of the video is how to identify the Sentinel loop, okay? And that's because we're looking over and over again for a particular value. And the second half is how do you do the Sentinel loop, okay? So a very common format is this do while, and we're going to look now at trying to figure out whether a do while works or whether we need to do what's called the loop and a half, okay? So in this case, we are going to compute all these numbers until we get to this desired dice sum. But remember the cases where we had, let's say, the user was adding a bunch of numbers until they entered -1, okay, and you had to throw that -1 away, okay? In this case, we don't have to throw the -1 away. But suppose that what we're trying to do is when we would keep on doing this loop until we got a dice roll that was greater instead of desired. Okay, we wanted to do it until we got a dice roll that was greater than the number that was entered. So we wanted to do it until we got a 10 or 11 or something. Then, if we did that, and let's say we were keeping a running total. Okay, that's another crucial part. If we did that and we were keeping a running total, we would want to throw away the last number. Okay, well, let's just assume that we want to throw away the last number, because remember those ones like where it was cumulative, we wanted to add all the numbers until we got to -1. So if we treated it the same way, this isn't going to work because the last one is going to be added into that calculation. In those types of cases, what you would want to do is you would want to do what's called the loop and a half, which is the same solution used for fence post problems, but it can be used for Sentinel loops. In that case, what you'd want to do is you would want to get the first two values before the loop and then reverse the process here. Instead of a do while, have it be while do. So the while would check to see whether the sum is greater than the desired value. And only if the sum is not greater than, then go through and add the value and then generate two new values. So that's the case in which it's not going to be a do while, but it has to be a while do. That is not the case here, but I just wanted to clarify. All right, so I'm not going to go any further with this problem. You're going to have to figure out the exact code yourself. But let's review what this problem was about. So diceSum is about two things. It's about Sentinel loops and it's about random number generation. So actually it's about three things. It's also about a scanner input, right? So a scanner input, Sentinel loop, and random number generation. And what did we learn here? Well, let's see. We learned about how to combine the scanner loop with a Sentinel loop, the scanners with the Sentinel loop. Okay, that's a little bit unique. I spent some extra time talking about how you can identify a Sentinel loop. Okay, you identify the Sentinel loop because we're looking over and over and over on some process until we get a specific value. And then I also talked about how do you solve the Sentinel loop. The simple case is you can just do a do while. Okay, there are cases where you have to throw away the last value, and in that case we have to use the same process we used as for the fence post loop. And we have to use the loop and a half solution. We're going to do the half loop first, and then we're going to reverse the operations in the main loop. Okay, so those Sentinel loop and the loop and a half solution are two very important structures you need to know for this course and for programming in general. So if you found this video helpful, please like and subscribe. I do have a full curriculum on the Building Java Programs book. Thank you very much.